Good morning. Well, we have our guest, Marc.licharz. Hi, Marc. Good morning to you. Good afternoon to you.
Yeah, yeah, thank you.
Okay. Well, we wanted to make a follow-up video regarding applications and how specifically we can use the Linnotam material. Marc, tell us a little bit about the usage of Linnotam and Linnotam Glide.
Um, Basically, Linnotam is well, we talked about it a little last time. Linnotam is an engineering plastic which is used for industrial equipment. Anywhere where you have industrial equipment, where you have rubbing against one another, where you're looking for weight savings, corrosion resistance, really the advantages that you have of plastics in general, is where you can use Linnotam. And then, although you do have to look at what are the general characteristics of Linnotam in particular versus whatever other plastic you might be considering, but Linnotam is basically just unfilled nylon. Just a regular, your basic nylon. The Linnotam Glide has an oil additive, and that's basically in there to make it a little more slippery. That it glides better, it wears better. If there's friction, we have Linnotam Glide. We have Linnotam Glide Pro T, which has a solid lubricant additive. And we have a Glide Pro TX, which is a combination of solid and liquid lubricants that are actually not just embedded in the material, but integrated into them.
Yes.
And so we have sort of if you want to take the degree of slipperiness, you have the Glide, you have the Pro TX and the Glide, the Pro T, and the Pro TX, with the Pro TX being the most slippery. But of course, you're going up in price.
Okay.
For those as well.
And Marc, tell me, well, since we're speaking about Glide, one of the things distributors and people say here is how does it compare, for example, to UHMW, the Glide?
Yeah, it's an interesting comparison. It's UHMW is a great material for friction applications where you have parts rubbing against one another. You want to reduce the wear. You want to reduce the friction, and it's great to machine everything, but it's not good when you get into higher loads.
Okay.
So if you have an application where you have high loading, the UHMW isn't going to perform well. It's going to wear out quickly, and that's where our Linnotam Glide would come in. It still provides a good coefficient of friction, but it can it handles the loads very well.
Okay. And let's talk a little bit about pulleys, because that's probably one of the big applications of the regular Linnotam, no?
Yeah.
And it's quite used here everywhere in construction, ports, logistics centers.
Yeah, and that if I compare that to UHMW again, UHMW is pretty much strictly used where you need the characteristics of it being a low coefficient of friction.
Yes.
But the Linnotam you can use it in a wide variety of settings. So, for example, you can use the Linnotam for pulleys where there's high loading, where the friction of coefficient doesn't really matter. You're going to install an anti-friction bearing in the center, and you have going through the groove, you have the wire rope. You don't need a slippery material for that. You need a strong material, and that's the Linnotam. Mm-hmm. But if you need for a different application a slippery material, you can take the Linnotam Glide and get good performance out of it. So yeah, the pulleys, we sell a lot of the pulleys to mobile cranes. So it's when I tell my friends, they ask, well, so where does your plastic go? I say, well, those big construction cranes you see everywhere? I said, yeah. I said, the pulleys where that big weight hangs on, I said, they're made out of our plastic. And they usually look at me and say, that's plastic? I said, yeah, it's a much different plastic from a plastic cup. But yeah, it's plastic, and it's made to take those loads. So it's really, we consider it a real industrial plastic, and not a commercial plastic.
Okay.
And obviously, since the pulleys, that's almost one of our first products way back at the beginning. And if they go into cranes, a lot of the cranes have hydraulic booms.
Yes,
that's
absolutely. Oh, yeah, yes.
And they were using, I think, bronze wear pads. So the metal booms were running on bronze wear pads, which obviously was noisy. They wore out. And so what we did is we developed then the Linnotam Glide and said, run those booms on Linnotam Glide. And that's how we got into the Glide material. So now, just in different shapes, if you imagine just a regular straight boom.
This is a wear pad for a crane boom, yes?
Yeah, well, this is probably not for a crane. This is probably for a forklift.
Yes, yes.
And this would get a couple of holes in there so that you can mount it properly. But really, this is the surface that would get worn down.
Yes.
And so what you're doing is you're wearing out this little pad as opposed to wearing out the expensive boom.
The boom, yes.
So that's a little one. Let's say this is a slightly bigger one. This would probably be for a small crane. See if you can see that properly.
And Mark, one question: what's the difference in color? What's the difference between the yellow?
Just color.
Just color. There's no okay. It's the same material, yes.
We make it in black, and we make it in yellow, and then the Pro T we make in standard in gray, but we also make it in red. But really, it's just a color additive.
That's very interesting. Those two, the pads, the one for the forklift and the bigger ones, you provide the material and also you can provide the end product, I understand, yes?
Yes.
Okay,
we supply the semi-finished material. Most of the finished parts we do we supply within Germany, though, just because the lead times and sometimes the language and the drawings and the technical discussions for finished parts, it's a little tough if we're dealing with the big distances.
Okay, and if a distributor, for example, would ask for suggestions because they know the crane, they know the application, and if they need technical support to design the wear pad, would your technical staff be able to help them?
Yeah, I mean, as particularly with the pulleys, there's a whole bunch of information we would need in order to make a good recommendation. But they could get in touch with our applications engineers, and there's a worksheet that they can fill out, and based on that, they can make a recommendation as to what load or what bearing to put in.
Speed as well, probably, yes.
Yeah.
Yeah, perfect. Okay, Mark, well, thank you very much. This is
You're welcome.
Quite interesting. I got this specific question regarding pulleys from one of our big distributors. And as you know, I'm flying to Peru next week and also be talking with plastic people there. And they're usually quite interesting. And if I have more questions, of course, we'll follow up.
Yeah,
right?
Definitely.
Okay.
Well, thank you very much.
Oh, I appreciate it. Great. Thank you very much, Mark.
Bye-bye.